So I'll put all the energy solutions under E and then the subtitle for a specific topic, a specific portfolio of energy. So the first solution set we will run through is on energy. We'll start with wind turbines. So here it is ranked for 2050 for onshore and offshore. This is the amount of reduced CO2, 84.6 gigatons for onshore. I think you know what onshore and offshore is. The net cost is $1.23 trillion in some pegged dollar for baseline, and it's ranked number 2. The net savings is $7.4 trillion by considering the various criteria that we briefly mentioned. But just keep in mind that the net savings are much larger than the net cost. So just try to track those numbers without worrying too much about the details. Offshore saves 14.1 gigatons in CO2, costs less than the onshore, and net savings are also about half of the net cost. Okay. The idea of onshore and offshore and where we are headed, I took some figures from IRENA, the UN agency report, International Renewable Energy Agency. This lists various aspects of the wind energy offshore and onshore going from 2010 to 2050, and then tries to see whether we are on track or not. Let's look at just a few of them. Wind power in total generation mix, onshore and offshore wind generation share. We went from 1.7% to 6% to 21%, expected to jump to 35% by 2050. So there is the progress. It's not that we are on track, but we are making good progress. Out of that, you can see that onshore in terms of gigawatts has grown tremendously already by 2018, expected to grow couple of orders, or at least almost triple by 2050, but it says we are really not on track in terms of the various goals that are necessary under drawdown to bring the emissions down to zero by, let's say, 2050. Offshore is making good progress, but obviously the issues are very different. Acquisition of land, wind energy potential, the net investments. Even, for example, in a neighborhood, you may have a backyard where you want to put a little windmill, but the homeowners association may say no because it reduces the aesthetics and makes noise, reduces the value of the properties, and also even in the open there is issues of bird kills and so on, for which solutions are being sought. An offshore wind grid, you have to worry about whether it has to be moved, so floating foundations, and for both of them you need to have a sense of what will happen in the coming decades. If you invest $1 billion in a wind park, for example, and the wind dies down in a decade, then what happens? So these are the kind of issues that one has to worry about. In terms of annual, so that's the total installed capacity. This is the annual deployment that's happening from 2010 to 2018. 50% increase, expected to go up more than an order of magnitude, but still not on track. Offshore wind, this is for onshore. For offshore, progress is good. So obviously offshore is doing pretty well, and onshore, even though larger in number, is still lagging in terms of the targets. Total installation cost for onshore and offshore. The main thing to note is that the cost drops with time, because there is just the labor training, the expertise that grows with more installations. There is the scale of economy, or economy of scale, and so on and so forth. So in terms of total installation cost, we are supposed to be on track for onshore and making good progress for offshore. Levelized cost of electricity. This is when you have different sources of energy, you have to find a way to compare them by levelizing the costs of each. So onshore and offshore, average cost drops for onshore and offshore. As you can see right now, offshore is much higher than onshore, but obviously it'll drop. Obviously installing windmills offshore is more expensive and will remain so marginally even over time, and either storing that energy or transmitting it back onto land where it's needed also obviously going to be more expensive. But we are on track or making good progress in terms of those costs as well. In terms of technologies coming online, if we look at global weighted average ratings for the existing systems going from 2000 to 2018, you had the rotor diameters of 50.17 meter with 1 megawatt capacity, going up almost 30-40% to 1.9 megawatts, and then 110 meters, more than 110 meters to 2.6. But we have coming online 158 meters and maybe 170 meters, raising the production per rotation to 5.8 megawatts by 2022-25 timescale. There are other factors involved: the materials, the loss, the storage, transmission, microgrids, nanogrids, and so on and so forth. So whether they are utility scale wind generation, wind power parks, or they will be on microgrids serving local needs of commercial buildings, industries, schools, neighborhoods, etc., all play into that. So this is the onshore wind story. Offshore gets a little bit bigger. You can see the biggest one is 170 meters here, whereas this is more than 230 meters. So average size of offshore wind turbines grew by a factor of 3.4 in less than 2 decades, and is expected to grow to output capacity of 15 to 20 megawatts by 2030, which is obviously an order of magnitude larger than onshore. This is the attractiveness of offshore, plus it's out there. Not as many issues as onshore in terms of land and other noise issues, maybe also bird hits and so on. The turbine ratings here in terms of megawatts in existing offshore installations, we were up to 148 meters with 5.5 megawatt capacities, whereas upcoming turbines are going to take that to 164, 220, and greater than 230, raising the production to 15 to 20 megawatts in terms of weighted average or the turbine ratings in terms of power production. So good news there, and as long as the global warming doesn't simply reduce wind energy potential everywhere, this is a good thing. Looking at estimated floating wind potential in China for different depths and average wind power densities, just as an example. This has to be done for each country, like India, for example, which has coastline of 5,000 kilometers on the mainland and another couple of thousand around its islands like Andaman, Nicobar, and Lakshadweep, and so on. So various depths here, 0 to 20 and 50 to 100 and so on. Offshore area increases as you increase the depth, obviously. You go more offshore. Wind power potential increases in watts per meter squared. You can see significant increase there from 110 to more than 400. Wind turbine potential in terms of megawatts also increases almost 3.5 times, and the floating wind potential increases much more. Okay, so here are the concepts of floating foundation technologies. So this is the tension leg form. This is a submersible foundation, and this is a spar buoy concept. I'm not going to go into the details of these specific constructions, but you can find this in this IRENA report from 2018. I just want to give you a sense that all aspects of wind energy onshore and offshore are being considered, and there are many good news in terms of where we are headed and how the investments may become more and more attractive. Higher shares of wind power would be integrated in various G20 countries by 2050. So if you look at China, for example, here, compared to global, it's going to be much ahead. Global is expected to be about 35% by 2050, and China is betting big and may have 55% of its energy share from wind. Sorry, that's UK. UK is actually doing very well in terms of climate action and reducing its per capita emission as well, as we'll see at some point. China about 50%, and India at about 25% by 2050. Obviously, this depends on a lot of things in terms of where the neighborhood is and what are the other issues involved in setting up onshore and offshore wind power parks. Additional investments will be required in terms of grids, generation adequacy, and some flexibility measures such as storage, because wind is an intermittent source of energy, and also needs something called dispatchability, where for example, middle of the day, if people start cranking up fans and air conditioners, the energy supply has to meet the demand, and wind cannot be turned on whenever you want. So you need serious ways to deal with those kind of dispatchability issues, and entire electricity system has to be integrated to add renewables sources. So in terms of investments in trillions of dollars, current plans stand under 10 trillion. Energy transformation, it is a conversion from one form of energy to another. Could be that wind turbines are generating DC, for example. How it gets transmitted, stored, etc. may require conversion to AC, different voltages, and so on. The transmission grid, distribution grid, energy storage, smart meters, and dispatchable capacity. Some numbers are negative, which means there is bigger net returns than investments needed, and so on. So obviously we are not going to remember each and every number, but you need to remember the specific items that are involved in each of these solutions and the integration of those specific forms of energy into the overall grid. And there are many power system flexibility enablers in the energy sector. So generation, whether it's utility scale, local scale, distributed or concentrated, how the distribution itself will work, how transmission will work, how storage is going to improve, how the demand side management is going to be done with smart grids, microgrids, nanogrids, which we will look at in the next podcast. And sector coupling. There are things like combined heat and power, for example. Hydrogen gas is now being considered as a battery, for example. If you have hydrogen as part of the grid, then it can meet the dispatchability demands just like storage can. And electric vehicles, they are charging at some point, but there is a way to actually have them give it back to the local grid, microgrid, nanogrid, and so on, if planned properly. So those kind of sectoral couplings can also be part of the solution in terms of improving efficiencies. Estimated employment, this is going to be critical, especially even a rich country like the US, which struggled economically during the COVID in 2020, for example. All the stimulus plans had to argue for climate investment, but with the promise that they will generate new employment opportunities. This is also true for countries like India, where huge investments must mean new jobs. So the onshore and offshore wind jobs in terms of millions is expected to increase. So 4.9 additional jobs between 2019 and 50. Not a big number, but combining the net benefits, reduced carbon, employment, and so on, it is something to think about. There are, for each of the solutions, there will be barriers. I won't go into it each time, but I included this from the IRENA as well. So there are technological barriers, economic and market barriers in terms of market penetration. There are many issues. As solar and wind increase, their participation in the market, their ability to put back on the grid, how to fight with the utility companies in terms of their profitability, how to manage local grids and the intermittency and so on, and generally social acceptance itself are all issues. Regulatory policy and social barriers, and of course environmental barriers in terms of visual impacts, flicker, radar interference, noise, land area usage, public opposition, not in my backyard kind of NIMBY syndrome where people want wind power but they don't want the wind energy park in their backyard. They want it to be out there somewhere, right? Considering all this, the overall impact is that an increase in onshore wind from 2.9% of world electricity use to 21.6% by 2050 could reduce emissions by 84.6 gigatons of carbon dioxide. For offshore wind, growing from 0.1% to 4% could avoid 14.1 gigatons of emissions. At a combined cost of 1.8 trillion US dollars, wind turbines can deliver a net savings of $7.7 trillion over 3 decades of operation. That's a massive incentive. These are conservative estimates, however. Costs are falling annually and new technological improvements are already being installed, increasing capacity to generate more electricity at the same time or at lower costs. So, all sounds like good news, and we have to keep working on it to make sure that we're on track and there are no unexpected barriers that we didn't account for in terms of governance and other issues that I briefly mentioned. Okay?